Hi folks. So we have a quick problem to talk about um, concerning work done by several different forces on a system. So the problem reads, a 5 kilogram block is pulled across a table by a rope. The tension in the rope is 30 newtons. The coefficient of friction between the block and the table is 0.2. When the block has been pulled 3 meters, what is the work done by tension, the work done by friction, and the work done by gravity? So first things first, of course, probably want to draw a quick picture. We're told that we have a table here. Let's draw a little modest box. It's not too bad. It's being pulled across by a rope. We're saying that tension in this rope is 30 newtons. This is a 5 kilogram block. Right, make sure that we got that, 5 kilograms. Right, we know that mu k 0.25, nope, 0.2. What else do we know? We know that we have moved a total of 3 meters. Which is going to help us figure out our work because that's our displacement. So at this point, we're still talking about work. Remember that work is going to be defined as F dot delta x for most scenarios. It really is a path integral. We talked about that. But for this problem, since we're going in a straight line, and our forces are all constant, we really just have F dot delta x. So I need to look at the individual forces here. I probably want to draw a free body diagram. Right? What forces are at play? The easy one is always gravity. I have mg. I'm not accelerating through the table here, right? And I'm not flying off the table. So I need an opposite and equal force of the normal force from the table on my block. I'm given that there's tension, and if I'm moving to the right under the influence of this tension, I know that I need to have a friction force, right, to the left. So, if I want to know what the work done by tension is, I can start to apply this formula. I can say the work done by tension is equal to the force of tension, right, 30 newtons. Let's actually go ahead and rewrite this equation as F, the magnitude of F, times the magnitude of the displacement times cosine of the angle between F and delta x. So I have 30 newtons for my tension. I have a displacement of 3 meters. Now if I think about the displacement vector is pointing this way. My tension vector is pointing this way. What's the angle between these two arrows? Well, it's 0, right? They're pointing in the same direction, and so the angle between them is 0. 0 degrees. Of course, cosine of 0 is 1, so I'm really just left with a total of 90 Newton meters, which we said in a video that is a joule. So we have 90 joules of work being done by tension. 90 joules. All right, so now what about friction? What about friction? Well, to do friction, to talk about the force of friction, well, I'm going to need Fn times mu k. Fn, if I quick do a sum of the forces in the y direction, right, I'm going to see that Fn minus mg equals 0. So Fn equals mg. rewrite that up here, mg mu k. Let me just move, oops, let me just move, there we go, move this down here. So if I'm thinking about the work done by friction, right, I have mg mu k, I have delta x, and I have cosine of the angle between them. Plugging in some numbers, 5 kilograms, 9.8 meters per second squared, times 0.2, times 3 meters, times cosine. Well, let's look at our arrows here. Right? If I think about my displacement vector, I am moving this way. If I think about the direction of friction, though, it's moving this way. So what's the angle between these two vectors? It's a full 180. 180 degrees. 180, if you throw that into a cosine function, you get -1. I'm going to get, if I plug all this through here, I should get -29.4 joules. And it's negative because we are moving opposite the direction that the force is actually acting on it. So it ends up opposing and taking energy out of our system, essentially. So our last question here, so we can write that in, right? -29.4 joules. So our last question, how much work is done by gravity? Gravity, we know, right, if G equals mg. So if I think about the work done by gravity, I'm saying that that is equal to mg times delta x times cosine of the angle between them. I've said this before, I'll say it again. Our displacement pointing to the right. Our force of gravity, though, points down. There's a right angle between them. Right? So cosine of 90 degrees, that whole thing is 0. Anything multiplied by 0 is still 0. The work done by gravity is 0 joules. This is one of those no work scenarios where my force, my applied force from the environment, is actually perpendicular to the motion, to the actual displacement. So it does no work. That's that. So we have different forces providing different amounts of work in the system, on the system, and that changes the kinetic energy in different ways. That's it for this video. Thank you for watching.